Good morning, good afternoon, everyone. Thank you for joining our Cognitive Systems Institute speaker series call this week. I'm happy to introduce Boaz, who is a research staff member at IBM Research in Haifa. He holds a bachelor's and a master's degree in computer science and information technology, both from Technion University in Israel. He has worked for IBM for almost 18 years and has spent the last 10 years on healthcare information technologies and recently moved to work on learning technologies for natural language processing. Boaz was part of the Argumentor team that won second place in the cognitive hackathon recently run by IBM Research and Watson. And Boaz is here today to tell us what Argumentor is all about. So let me turn the call over to you, Boaz, and thanks for being our presenter.
Sure, thanks, Dan. Thanks for you for joining us. My name is Boaz, as said, and I work for IBM Research Lab in Haifa. And I'm going to talk to you today about the Argumentor initiative and application, which is powered by the debater technology. I'll talk a bit about the debater and then about Argumentor. And Argumentor, short, is a legal aid, an advisor and mentor for young attorneys. So the agenda for today, or the things that I'm intended to cover, is a short introduction about and background about the debater grand challenge that's run here in IBM Haifa. Then I'll talk a bit about our technology focus, which is what we call pro-con analysis via machine learning, deep learning for natural language processing. Then I'll show you the Argumentor application, which is demonstrate the pro-con analysis capabilities at the legal domain. I hope to run a short demo, but currently there is a problem with the server, so maybe I'll just go through several screenshots and show you how this works. And then I'll talk a bit about our university relation aspects, few things that we are doing currently with university and what we are looking for and intending to do in the future, and we'll conclude with a short summary, and we'll leave about 5 minutes to questions at the end. So this is a bit about the debate, what we call the debater grand challenge. This is the grand challenge. The debater grand challenge is running here in the IBM Haifa Research Lab for the last 3 years, and there is about 40 people working on that. And the aim of this is to develop technologies that assist humans to debate and reason. And we are about to create a full flow of a debate in which we are, getting a topic and extracting claims and provide our speech, and then everything, the system is done automatically, and then it responds to the opponent speech, and at the end there is a declare who won. Somewhat similar to what happened in a contest in Jeopardy. So the debater vision is that an intelligent system able to take raw information and digest and reason on that information to understand the context and to construct arguments, pro and con, any subject. So we are getting a subject, a topic, and then we are able to digest the raw information and extract arguments for that, both con and pro. So the debater used a complex analytic pipeline, which we call argument construction engine, or ACE in short, and this is what you can see in this figure. So it's running left to right. As you can see at the bottom, there is a huge amount of technologies that is being used, both text analytics, machine learning, and information technology architecture. We use the NLP and similarity measurements. We do supervised and unsupervised, and currently introduce deep learning into that, and use many resources like WordNet, Wikipedia, DBpedia, and so forth. And the pipeline goes from left to right. It starts by getting a topic analysis. And then what we do is called the claim-oriented IR. So we are actually retrieving the claims for that topic, and then we do claim detection, which extract specific sentences from each of the claim or for each of the text. And then there is something called evidence detection, which basically for each claim detects the evidence and then runs the pro-con analysis and eventually the argument re-ranking. The thing you see in bright, the claim IR, the claim detection, and the pro-con analysis is being used also in the Argumentor application that I'm going to talk about. So that was a short background about the debater in general. And what we are focusing on in Argumentor is what we call the pro-con analysis. And a pro-con analysis is fairly easy to explain. So the goal is basically given two related sentences, and first you need to understand what related sentences are. But assuming you give two related sentences, which one is a claim and the second is an evidence, and again, as explained, this is one of the outcome of the debater, or given a thesis and a fact, or any other two sentences, the goal is to determine for each pair whether the second supports the first, which we call pro, or contest it, which we call con. And as you can see here, there is a specific example from the legal domain. So in that regard, a claim is the first sentence and says an evidence obtained from a search without warrant cannot be used in court. So this is a claim that we can find in many cases. And then we look at the text for evidence that justify, support this claim or contest it. So an example for an evidence that supports that claim, you can see it here. The Fourth Amendment provides that the right of the people to be secure in their persons, houses, papers, and effects, again, unreasonable search cannot be violated. So again, keep in mind that these two sentences, they are coming from legal cases, texts that we can extract, and the idea is to extract these automatically, find these sentences, and then provide them in a context that says the second sentence supports the first one. Or a con example, as you can see here, it's like it is frequently argued that in dealing with the rapid unfolding and often dangerous situation on city streets, the police are indeed in need of an escalating set of flexible responses graduated in relation to the amount of information they possess. So this actually, to some extent, contests the claim sentence that says that search without warrant cannot be used, or evidence from search without warrant cannot be used. The next slide show in a very high level, the overview of the architecture that we use for this pro and con analysis. So it's basically capitalized on deep learning. Deep learning is a promising machine learning subfield that's gaining huge momentum lately, and there is a lot of activity around deep learning. Basically because it's currently beat state-of-the-art algorithm in many areas, including computer vision, speech recognition, and also NLP, natural language processing. There's a lot of work both in academia and IBM Research and other companies about these. And it's basically a complex system that allows you to, given a substantial amount of data, it can learn almost anything related to natural language processing and other like vision and speech. So here you can see the idea of the architecture is that you give it two sentences, sentence one and sentence two, and we use something called recurrent neural network. And we have two of these for sentence one and sentence two, and then on top of that there is a classification layer that eventually at the end need to provide an output that says whether these sentences support each other or contest. So this is the core technology of the system that we build. Okay, the next slide show actually the domain that we work at, or the use case that we choose. So as we said, for the debating technology, there is many possible industries that need for that, and domains like you can think of health, in which you want to find argument for whether, for example, a drug is good or bad for you, or in education, that you can help teachers, or in finance, where you can want to find the best investment, for example, and in legal, which is the core of the argumentation area and debate. And specifically, we targeted Argumentor on young attorneys which usually takes the role of a general associate in mid-large law firm. And we basically choose this use case from help with Watson Group and after some market research. So you can see some numbers here about this field and what we can do with it, the money that we are targeting, and why we choose to work on that domain. Okay, now I intended to show you a short demo. I think that there is a problem right now with the server. I'll try to do that, but if it won't work, I'll just go through some slides that show it. Let me try again. Okay, so currently there is a problem with the server. I will do that through screenshots. I hope I have them here. Just a second. Okay. So I'll walk you through the application. It's basically a concise and a targeted application, as said, to legal research. So the use cases we envision is that our attorney, she get an email which describe a situation about our client, and then she just cut and paste this email, as you can see it here, into the application. And then we use what we call the concept extraction, in which an automatic system, a cognitive system also based on the Alchemy API, if you're familiar with, which is an IBM-owned subsidiary that has a lot of cognitive services. So it extracts the key concepts from the text. And we can, of course, edit that, remove some concepts, and add some concepts, as you can see at the bottom of the page. And then what happens next is that we are searching for a huge amount of legal data, and using the debater's ace, as explained, we construct the arguments. What you can see here is a list of arguments that are, as we find, the most relevant to the case at hand. So if we go back to the case, you can see that we are talking about a client that's standing at the street corner with a backpack, where the neighbor is with drug dealers, and then the police, he was standing there for 30 minutes, and when a police officer approached him and demand that he submit to a frisk search. So basically, it's talk about search and whether the drug that has been found can be used or not in court. So while extracting the argument, we are looking for these keywords, and we are argument that support or context this issue or the issue at hand. As you can see here, there is several arguments coming from different cases. So you see on the left the cases that these arguments come from. And on the right, there is a couple of icons that allow us to continue to work with these arguments, as I'll show in a second. So this slide, the third screen, basically show you like high-level view of the cases summary and the most relevant cases to the issue at hand, and for different petitioners, whether they win or lose this case and so forth. So like high-level statistics related to the subject that may help the lawyer to decide whether he has a case, in court or not. Here you can see we can go again deeper into those most relevant arguments. Okay, there is the most relevant argument, and there is a few additional information about each of the cases that contain the argument, like whether there was a landmark case, whether it was on the news, and who won that, the conservative or the liberals. Later on, what the system can do for the user, for you, is basically what you do, you go on several arguments and mark them whether you think that these arguments support your client or contest its case. And after marking several of these, the system actually goes and cluster the rest of the argument based on similarity analysis to the argument that you mark, and then you have like two groups of arguments that support your client and those that contest it. Okay, so by that, this is basically the short demo that I have, and I apologize that the server is not working and you cannot see it in live, but the URL is here and it's basically open, so you can go and try it yourself once it will work. So these slides show you the high level architecture of the solution. So as you can see, it's composed from several components. First, there is a set of services running on what we call the IBM Next, which is an IBM Research Cloud that allow you to run many services remotely. Then we use the Watson Developer Cloud, as I said, things related to the Alchemy language that allow us to do the keyword extraction and several other things, and also what is being called as natural language classifiers that allow us to classify arguments. And then eventually what we do is we are actually annotating legal cases, and these is being fed to the system as learning examples. And based on these, we learn, and the IBM Argumentor that's here in the middle can then analyze these text annotation, and then while getting new topic or new case to analyze, or incident to analyze, it can go back to what it has before and then extract the claims and the evidence for that case and provide you with the pro and con analysis for these arguments. Okay, so with respect to the cognitive elements in the system, so first there is the argument construction, which is a deep neural language processing based. So argument process legal cases for detecting arguments based on technology from the debater grand challenge, as I said. And then we have like natural language input, of course, which, as I said, the input to the system is like an email cut and paste. So it's a very a description of an incident in a natural language that we can just insert into the system, digest it, analyze it, and start to work with it. It provides interactive capabilities with the user, and seamlessly integrates into the current flow of the legal professional. I said processing and then allow human feedback at each step. As I showed you, you can add and remove keywords, and then you can, when you have the argument, you can rank them and say who are more important than the other, and then it can learn and classify the arguments based on the feedback and the input from the user, like in something what we call the online learning. And finally, it helps the user to focus on what is of interest by interactive highlighting of the most relevant argument. We use supervised machine learning. For this hackathon, we annotated sample data of real legal cases to teach the computer to classify and evaluate arguments. And this is actually one of the tasks that we are continue to work with legal experts and domain experts and with legal students and professors at universities to help us annotate legal cases at the best way, and how, what will be the best method to learn from. And I will talk about this a bit more in the next slide. So with respect to university relation aspect, which you probably most interested in, so we started by, we recently won a legal argument structuring and gamification your country project, and we use that in order to facilitate the interaction that we have here in Israel with the Institute of Legal Implication of Emerging Technology at the IDC, the Interdisciplinary Center in Israel, in Herzliya, Israel. So we started by giving 2 lectures at the Institute. And the lectures was actually related to first machine learning and then AI and its legal implications and what is AI in general. And then we are continuing with working with a group of students, mainly on legal case annotation, and trying to come up with annotation guidelines, namely how we can annotate cases in a way that allow us later on to, allow Argumentor and similar applications to learn from. For example, how you annotate pro and con sentences, how you annotate the differences between what was the question at court and what was the decision and so forth. But, and the ultimate goal, which will take us some time to get into, is really to reason about the facts in the case and say something about them. We are starting to work in collaboration with Robert Jan Siep in the Netherlands. We apply for the university program for a PhD fellowship for crowdsourcing. And his research is mainly on the relations between crowdsourcing and niche sourcing. And we are trying to come up with a research in the legal domain that allows us to do this. We are also investigating an annotation platform, such as Crowdflower and the Watson Knowledge Studio for this task of how domain experts can work with us in order to structure and annotate legal cases that we can then learn from. So to summarize, the debater provides leading technology for argument construction. An Argumentor is a cognitive application that assists young attorneys in a legal research task, and it's based on argument construction pipeline, namely claim detection and pro-con analysis. And then for collaboration, we are looking for collaboration with the law schools and universities that provide us a jump start into this domain, which is complex, and we need to assess and research exactly what can be done immediately and what needs more research and more data to achieve. And the last slide is just a thanks slide for the team that work on the Argumentor application development. As said, it was part of the IBM Research Hackathon that ran at the last summer. So it was a cooperation between IBM Research and then Watson and emerging product and implementation. And you can see the people here on the slide. And yeah, thank you. And that concludes my presentation, and we have a few minutes for questions if you have.
Thank you, Boaz. That's very interesting presentation, and your timing is perfect. For the audience, if you have a question, you need to unmute. If you're using your audio on the computer, there's a microphone button at the top of the screen. Or if you're on the phone, you have to press *1 to unmute your line. Are there questions for Boaz?
Hi, Boaz. This is Jim Spohr. Thank you for a fabulous presentation. I'd like to, you probably already know Lillian Wu on my team, but if not, I'd like to get you connected with Lillian because she's starting to develop some use cases for our university team. I'm wondering if there's any of these capabilities we could start using in some of our university activities to help us as we're doing things with universities.
Sure, thank you. I would be very grateful if you'll do that. I'll be happy to talk to her.
Sure.
Boaz, on the demo, you said it's open, so anybody on this call can go and try that out. What is the corpus for the demo?
So we built that on 7,500 U.S. Supreme Court cases from, I think it's written here somewhere, but there are past cases, I believe, from year 1945 to 1975 or something like that.
Interesting.
Boaz,
Go ahead.
Hi, Boaz. You showed some examples of pro and con arguments for a particular claim. Can you imagine the system doing more complex reasoning, so not just pro and con, but maybe a more complex reasoning of why and related arguments and so on?
Mm-hmm. You know, I can imagine, but to be honest, even these tasks are fairly complex at this point. So we are investing a huge amount of time just to first identify and extract these sentences. So what is a claim and what is an evidence? If you think about it, even this stuff, it's fine. We find it very complex to do because keep in mind the computer knows nothing, right? So it just needs to learn from past examples about how a claim look like in order to understand that this is a claim. And then it needs to understand what the evidence of a fact is. And later on, it needs to associate between the two. So to understand that this sentence already relates to that claim. So of course, you know, we all want, and the goal is to get into reasoning and to allow computer to reason. And you know, someone can of course envision or imagine that at the point in time in the future, I don't know how many years from now, a computer will be able to reason like similarly to what a judge can do. But I think we are still far away from that point, and we are just starting understanding natural languages. So
can I ask you a follow-up?
Yeah, go ahead.
So the example that you have on your slide right now, the con argument is actually quite difficult. Is that something that the system automatically came up with? And in that case, is it also, can you also give some weight of confidence? So the first one is the pro argument. You can probably be very confident it's pro. The con argument seems quite difficult to say that it's con.
Mm-hmm. So again, to be honest, this is just examples that I put in. They are complex to achieve. And of course, we will have a confidence level. This is like inherent in most machine learning algorithms, so we will provide them. And at this point, I cannot tell you, you know, how far can we go. We are just starting, and we are planning for a fork on this. Actually, it will not be on that domain; it will be on finance. Because we found, after looking more deeply into legal, we found that legal is really complex. You know, you need the brightest human brains in order to reason on these issues. We are in the level of extracting evidences, you know, and extracting claims. This we can do and provide what we believe as the most relevant claims for a case, and maybe associate an evidence with a claim. The pro-con analysis is at the end of the pipe, as you saw, and we need to see how far we'll go with that.
Thank you, Boaz. Thank you for the question. And we're about out of time, so I would like to suggest that we continue the conversation and questions for Boaz on the LinkedIn discussion group. I'll post something out there in just a few minutes. And just want to thank you, Boaz, very much for this wonderful presentation and the work that you are doing in Haifa Research. Thank you, audience, for attending, and we will see you next week. Frank Hsu from Fordham University will be our presenter next week.
Thank you.
Thank you.
Pleasure.